Welcome to Hack Boston. For those of you I haven't met yet, I'm Abby Fickner. Most people know me as Hacker Chick. I'm really excited about Hack Boston. I am a developer who's really into the Boston startup community, and there's all these awesome startup events, but they're almost all on the business side of things, which is nice, and I guess we need that, but I'm a developer and I want to play with new technology. I created Hack Boston to kind of fill what I saw as a gap, because I think what makes us really awesome here in Boston is our wicked smart technical people and the fact that we're known for just solving the really tough problems and constantly recognized as the most innovative city in the world. So I wanted to do something where people could come and kind of get hands-on with the latest technologies and learn some new stuff, meet some new people, and maybe be inspired to create more awesome stuff. So that's what I'm doing with Hack Boston. I'm really excited about tonight. I guess what I want to do is kind of go through the community and find some of the techies doing amazing things like Reed is, and see if they'll come in and do a workshop to teach the rest of us. So I was talking to Reed and about what we did over our holiday breaks, and he's like, oh, I set up Dogecoin mining, and I started mining, and I'm like, that's awesome, do you want to do a workshop on it? And he said yes. So really excited to have Reed here to talk to us about cryptocurrency. For those who don't know Reed, he's probably most known for his work with Techstars. He's also at Project 11 Ventures. He teaches at both Olin and MIT. At MIT, he teaches a class with Sir Tim Berners-Lee. So he's kind of a big deal. And it's kind of really awesome that he's here tonight. So thank you for being here, and I'll turn it over to Reed.
So I know that there are many people in the room. I like this because many of the people in the room know a lot more about this stuff than I do. So I definitely feel like a hacker, meaning the only way I learn things is by trying them out. But at the same time, I really don't have the patience to go super deep. So I started playing with this stuff to try to learn about Bitcoin last summer. During spare time over the Christmas break, said, oh, I should learn a lot more, and realized that Bitcoin has gotten so competitive and speculative that some of the stuff is really, the software is really hard to do, and some of the apps, there's a lot more creativity among the people who are building around the newer, younger altcoins. So there's things you can learn by sort of playing with the early stuff in the other coins. So that's what led me to, and I have to say, how do people pronounce this?
It should be doggy.
Doge?
Doge is funnier.
Doge is funnier.
I like Doge.
Doge? Okay, so I first started hearing about it as Doggy Coin, but now I've totally flipped over to Dogecoin. I do know that if you pronounce GIF, it's GIF. The guy that wrote it told me that back in the 80s, so I still believe him. But I don't know about Doge. So for today, we have this online. I made these world editable, so people will be playing with them. That's okay.
Oh, I'm doing that right this second, actually. Look at what you're missing.
So we have a couple resources that people can get to online, because the evening will get a little bit chaotic as everybody moves at a different pace. So this Google Doc is the one that's bit.ly/1000 Doge. And then in the top left, there's a link to a text document, which has kind of a set of links to downloads and resources and apps and that kind of stuff. So if people are stuck on something and you actually know the answer, feel free to add it into the other resource. So I'll just flip over so you see what that is. So this has at the bottom a whole bunch of reference links, and then has at the top roughly what I thought we'd try to get through, but I'm open for suggestions. So,
how do we get to that page? How do we get to that page?
In the top left cell of the spreadsheet, there should be a link to this page. Okay, so first questions. Who has bought or owns or mined? Who is holding Bitcoin? Okay, cool. And who has mined Bitcoin?
In a pool. Does that count?
Cool, cool. And who has mined some other kind of altcoin? Okay, which ones?
Dark coin, Litecoin, Namecoin, Dogecoin.
Darkcoin, Litecoin, Namecoin, Dogecoin.
Yeah. Litecoin and Darkcoin.
Litecoin and Darkcoin. Who has done day trading, kind of currency trading on a with real stocks? Forget about real stocks, but like with the digital currency. Bitcoin. Okay, cool. Yeah. Okay, cool. Great. Who's used the ATM at South Station? Excellent. Yeah, excellent. Okay, so
Is it back up?
it was there when I came through. Yeah.
At Clover and Harvard Media School.
Cool. So if you want to buy Bitcoin with cash, you can do it at Clover and Harvard Square or at South Station. Okay, so this is some Japanese pet lovers family blog. This is the original photo that the Doge meme came from. And there's a person's hand kind of reaching out over in the bottom corner. So this turned into Comic Sans interior monologue.
So scared.
No filter. Such sponge. And this turned into very currency. Wow, much coin. How money? So crypto. Why? So Bitcoin, if you kind of are an outsider, it's like it attracts this cohort of libertarian, greed, grim, selfish, kind of like, there's a weird spin to it that these people reacted to. So it's kind of like, whoa, wait a second. Where's the humor? This is technology. This is fun. So around the Doge technology is this crosscut of community, generosity, we should share, we should raise money for the Jamaican bobsled team. and just that little bit of a brand meant that this is the Wall Street Journal, I think in January, the graph here, the bottom is, they're on the same scale. Daily transactions across the Bitcoin network and then daily transactions across the Doge network. So to me, that's kind of the power of a brand. There are hundreds of different altcoins, roughly very, very similar underlying technology. But sometimes, I mean, Dogecoin, Litecoin, there's not that much difference in the mechanisms and protocol algorithms, but there's a huge difference in the brand, and that's led to, you'll see with Dogecoin, it's very, very popular for tipping, and sort of like this really interesting reciprocal like button where the stuff's moving back and forth and back and forth and back and forth just as a social gesture. So that's part of what makes it also easy to play with and work with. Okay, so let's get started. How many, for everybody that has their wallet up and running, has got a couple thousand in it, why don't you find some neighbor, look up their address in the spreadsheet, and then send each other some currency. So where are your coins?
Ooh. Everywhere.
Everywhere.
Everywhere, yeah.
Nowhere. So the people that went to South Station to the ATM, did you notice they have a stack of little pieces of paper on top? So this is a picture of kind of a folded version of one of those. So there's even a concept called a paper wallet. So you can take this paper off the stack, off the top of the ATM machine, feed a $20 bill in, and scan this public address, an address. So you bought $20 worth of Bitcoin, and they exist at that address. So, but it's just a piece of paper. Where are the coins? Okay, so the wallet, if you rip open this somewhat tamper-proof, somewhat non-readable through the paper bit, you will see the other half of the wallet, so it's a key pair. You've got a public key, which is a destination, and this is why it's okay to have a shared spreadsheet with everybody's incoming wallet address. You know, kids can hold up signs with a QR code and saying, "Send me money." So there's no, I mean, it's receive only, so it's okay to be public. In this world, if you have the matching private key, that's only the people that hold that can send that coin, those coins. Okay, so there's a key pair. You can validate using the public key that, oh, there's a transaction where someone who says that from this wallet address I want to transfer some coins. Is it really them? And there's a mathematical way to say, yeah, no, you know, unless they had the private key, they couldn't have generated that message, that transaction. And that's about as deep as my crypto knowledge goes. So if there's other folks that have questions, other people, any questions on that rough concept? There must be, wait. I have a prize for first questions. You saw stickers on the way in? These are big stickers.
How much are you? Dogecoin.
So now does anybody have a question?
Yeah.
Okay.
What is different about the math for Dogecoins from, say, the math for Bitcoin or Litecoin?
Actually, that's a good question. That I don't know the answer to. Does anybody know whether the algorithm for the wallet, the key pairs on Dogecoin, the altcoins are different from each other?
It has to be easier, not just on the factor of numbers, this SHA-256, or I'll let the other guys do it. On Bitcoin, you know, it takes a lot of work, whereas Dogecoin, you can mine them.
But I think that's the mining side, yes.
You know, but the number of minutes it takes to go through the mine, you're talking about just how the difficulty of proof for it?
But on the identity.
He's asking about the algorithm for generating the key pair.
Oh, I think it was
So I can give you.
So, yeah.
No, go ahead.
Do
Go ahead. No, go ahead.
Oh, okay. So the answer is sort of, in alt currencies, it sort of depends that sometimes they accept alternate algorithms for generation, but from what I've seen, it's generally most people use the same algorithm for generating the key pairs.
So the answer from Brendan is yeah, typically it's the same algorithm for the key pair.
What algorithm?
Do you know which algorithm?
I do not.
I don't know. It's public-private key encryption. I don't know what it is.
Yeah,
MD5.
Okay, we'll pass. Thank you for good question. You stumped the So the answer to where are the coins is kind of everywhere and nowhere. So the people that set up your, in this case, they're certainly not in this paper wallet. The people who set up a client wallet, it took hours to synchronize. That transaction log is on all of your machines.
Do we download the entire blockchain?
Yes. Yeah. Which I think it's over 10 gig now for Dogecoin, but I don't know exactly how big it is. So that brings us to the next. So this is a little quick surf of the underlying technology concept. So the blockchain is this distributed. It's on each of your PCs if you set up one of these things. It's a distributed global transaction ledger. So every time you sent coins to someone tonight, you were posting something out to the network. It's like, hey, here's a transaction that I want to have out there on record. And if you were receiving coins, some of you may have noticed that it's like unconfirmed. And then if you hover over in your client, if you hover over one of the received amounts, you'll see that some of them have gone up to 3 confirmations, 6 confirmations. Those will keep climbing. So the blockchain is a globally distributed, a global transaction ledger that's distributed across the network. So there is no one. It's not like, in some sense, it's easy to think that a wallet is something like a FastPass or a MetroCard or a Charlie card where it's stored value. But there's no central database. There's no central server that you have to kind of go check things in and out of like that. one of the fun things about the blockchain is to make it trustworthy. I mean, to make this, you have to make sure there's no counterfeiting, double spending, forgery. So how do you create this trust that whatever transaction, great, there's a list going to the beginning of time that says, these coins were mine, or these coins came into existence and went to this address. These coins were requested to be moved from this address to that address by the owner. So someone you can confirm had that private key. So great, there's a list going back into time of what happened, when it happened. How do you know that those are legit? Why? It's like, okay, great, I'm in there that says, I want to give 50 coins to Ty. At the same next moment, I'm going to give the same 50 coins to Abby. How do you avoid that kind of stuff happening? So there's a lot of ways you could do it. You could have consensus. You could have voting. One of the interesting things about the Bitcoin stuff and these altcoins is they use this concept called proof of work. So if you make it expensive to add transactions to the chain, then you can avoid someone trying to fake the votes. I'm just going to create 1 million IP addresses that would vote that, yeah, that's a legit transaction. Yeah, we should take that. So it costs CPU power, it costs electricity in order to propose that something's added to the blockchain. So what you kind of see is there's the next clever, interesting thing about this whole protocol system invention on a social, in a social way is that why would someone invest the electricity and compute power to help validate and confirm transactions and add them to this global blockchain? What's the incentive? So that's the whole mining concept. So mining is a way for the miner to win a reward for doing the work of bunching together a bunch of proposed transactions and then throwing them back into the network. So the way it works roughly, and this is where I always have to go flip back and read the original Bitcoin white paper is a super lightweight, sort of layman's English for a tech person. So maybe it was written by someone who loved model trains and worked as an engineer for a living. It's definitely not written as kind of a hardcore computer science kind of mathy type of thing. So if you want to understand this, you can just quickly read the pseudo-English of the algorithm. So basically, I said I wanted to send Ty 50 coins. I used my client to do that. My client broadcast, if you hover over the bottom right-hand corner, those little icons, you'll see, oh, you've got 8 connections to the network. So I said, yes, send. That broadcast out a proposed transaction from me. It said, yeah, from this address, and baked into the client is my private key. So I'm going to create a message, sign it. Part of that message includes the transaction I'm proposing. The people who are mining are kind of listening on the network. Their job is to say, oh, here's a whole bunch of proposed transactions. Let me quickly make sure that there's no, that send from address really is not trying to double spend. So the miner is supposed to sort of say, look, if that same address, which had a trusted balance, is going to be under the balance by doing this, then I'm not going to pack it into this block. So the miner's job is to say, yeah, there's no double spend going on, and then I put together a block of info which includes all the pending transactions, the proposed transactions that I want to throw in there, my choice, a link to the previous blocks, so some data that only exists. So I said, okay, I'm connecting myself to the most recent block, and so it's a chain. Where I want my reward sent. If I win, if I'm the first one to solve the puzzle, I get something. And where do I want that to go? Now, and then I include kind of a random piece of data, a nonce, and then I'm running a hash algorithm, so kind of a one-way hash against all this stuff. And that algorithm is different. So Bitcoin uses SHA-256, and Doge uses script, S-script. So I'm in a race. I'm trying to solve this puzzle. And the puzzle is to hash all the stuff together and come up with a hash that has a certain number of leading zeros. And OK, I'm going to try with a nonce. I'll say, OK, maybe it'll work with this. Hash it. No. OK, change the nonce. Try it again. No. OK, try it again. The fun part of the incentive is it's a race. So the first person to find a way to put together a block and some random stuff, not necessarily random, but some stuff that creates a suitable hash, can post back out to the network and say, I found it. And they get the reward. Well, they get the reward after so that's the general idea, is that you are spending electricity, compute cycles, to try to find this math. It's hard to predict, obviously, kind of what set of data will create a specific hash. So you have to just try. And so you just crunch, 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 crunch. If you look at these mining, like, hey, what kind of graphics card should I buy? People are talking about, oh, this one you might, if you tweak it right, you might get 700,000 hashes a second. And so there's a huge amount of compute power being spent on this. It's a little bit odd because a lot of it is wasted. There's a lot of time spent by the people who are not finding that solution. But I think that's the social competitive part that actually drives putting a lot of power into the network. And you need that in order to have a trusted, verified, validated blockchain. So it's a really interesting, fragile mix of technical invention, social invention, kind of the people who are speculative or sort of trying to earn, make money or do stuff here, they have to pay for the electricity. So why are they doing that? At some point it'll be interesting to see how it all settles out. I'm not doing it exactly right. There's a bunch that I don't understand. Any questions? So is there a fixed supply? If I remember right, Dogecoin started off saying, yes, we'll have 100 million at the end of the supply. They recently said, no, we're going to be purposely inflationary, so add, I think, 5% every year. OK, thank you. Thank you. Good question.
Good question. So, are you saying that the mining can only happen when there's a transaction?
Can the mining only happen when there's a transaction? Yeah, transaction. You can't have a transaction in the chain unless a miner kind of did it. Do miners sort of mine tiny blocks? Oh, there's also, someone asked earlier about the transaction fee. The miner also collects the transaction fees from everything included in the block. So if you want to encourage people to include yours, then you can put a higher transaction fee.
Yes, I had a question. The question is regarding the blockchain and its growth. You said that it keeps growing based on transactions, and also it was thrown out about 10 gigabytes or so currently.
Yeah.
So given that the ball hasn't even started to roll down the hill yet, we're going to be downloading terabyte blockchains, or kind of.
There's a way to condense that, but I don't understand what a Merkle tree is, so if someone can explain. But yes, that is a well understood problem with some solutions, as I understand it, but that's like over my.
And then what happens with the asymmetry regarding the fact that this gentleman just brought up the issue that in order to have transactions there that are verified, you need to have them mined. So then you have to have legions of more miners than you have people doing transactions. And if this is a transaction-intensive environment, basically when you do the math, you have a pyramid scheme, and you're going to run out of both people and electricity to do this.
I'm not sure. Yeah. So
most of the electricity is actually just spent repeating the problem over and over again to try to solve the puzzle, and the actual compiling of the transactions is actually like a real small portion. It could handle a lot. you can read about it on Bitcoin's wiki. They talk about scalability, and they're capable of going much, much higher than they currently
And I
are.
think on the it's sort of like, imagine like a zip file. You know, if you go back 10 rounds ago, that's all sort of zipped. I don't think you actually, people have to, it doesn't get harder and harder and harder. They do make it harder because there are more and more miners, and they're trying to make sure that the solution only arrives every so often. But yeah, I think the wasting is just 10,000 people trying to work the same problem. But that's part of the game.
Yeah, so the threshold difficulty is adjusted like Tyler was saying, right? So if there's not enough miners, then the threshold is going to go down. It's going to become easier for those, and presumably more people will come. And there's some equilibrium.
That's a good point. So the effort required to confirm, to validate block is adjusted by the network, the protocol.
It's adjusted
So-
every 2 weeks.
And that's used to,
Yeah, every currency
Yeah, for
adjusts
Bitcoin.
differently.
Yeah.
So
Yeah.
like Darkcoin adjusts like every couple minutes.
yeah, that's one of the interesting things. If you look at the different altcoins, that's one of the parameters they changed. But with Bitcoin, it's like, so if I understand with Bitcoin, that's also how you control the rate of growth of the supply. You know, you increase the number of leading zeros required to have a solution, and it self-adjusts every so many thousand blocks to try to make it 10 minutes of clock time.
Yeah, it's targeting a block being
Yeah.
solved.
So the more power you have in the network, the harder it gets. If people back off, it gets easier. Aaron, you want to talk about mining? The whole question about transactions? Can transactions happen with it? Why does it?
Yeah.
Can transactions? I want to do one, but it never happens, and that kind of stuff, or
So is a miner creating a transaction when they mine?
Yes.
That's
So like the
That's-
payout goes to the address that they store. So as the miner, you can specify the address that the payout for that finding that block goes to. I mean, most people will be their own
so
address.
who's
but
paying this?
that's sort of this magic a priori.
protocol generates.
Like it's the random hidden numbers that are
You know,
out there
25
waiting to be found.
in Bitcoin
From nowhere.
get done every time.
They're not from nowhere, though, right?
No,
they're,
from
they're
the-
all there right now.
Correct.
From the monetary
Correct.
supply, you just increase the monetary supply.
So mining is a transaction in and of itself, and it's transacting to yourself from this pool of
Gravitational waves.
yeah.
Yeah.
Questions.
They're there now in the sense that the protocol has been written such that there's supposed to be 21 million.
21 million.
But like Reed mentioned earlier, Dogecoin started out with a targeted load, and then they decided to change that.
Well, so the everyone in Dogecoin or Doge could decide to do a hard fork and be like, screw you guys.
And say we're going to change the limit.
and
I
I
think
think
that, I
that
believe
will
that's
happen over
possible,
time.
and
They're
that's
gonna
not
have
talked about in
forks.
Bitcoin at all. Everybody says always, oh, 21 million is a hard set number. But
that
I don't
could be a
think
fork.
I don't think it actually is a hard set number. If the miners agreed to change
enough.
it, they could.
And even if a small population agrees, they could.
No,
go,
50. It's got to be 50.1.
If they want the whole pool to change.
Of the existing
If they
chain.
want to do a
Coin,
hard
though.
fork and then force everyone into their fork, sure, they have their 51, but they could just leave and start their own fork anytime they want to.
Yes. It's like when there's like recently there was
No,
this.
the other side would accept their.
Yeah, there were a couple of hiccups with Dogecoin over the last few weeks. One by design, this most recent one, where they're like, look, we're going to change the protocol after block 145,000. Everybody catch up. If you got some software out there, you got a mining pool out there, we're just going to do this. And then there's every now and then it can be something where you have a very long, like a fork in the blockchain, and then people have to kind of get together and say, whoa, 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 no, that's the one, which is a bizarre thing, but that's beyond.
So an important part of the proof of work is that the network defaults to the longest chain. That's how you
Yes.
that most work went into it because it's the longer one, right? So sometimes there's these race conditions where there's two people find the same block at the same time,
Yeah.
different parts of the network, and it may sustain itself for some time before one actually gets long enough to dominate and take over.
That's why you wait. That's why you wait a certain amount of time.
That's why if you,
That's why
yeah.
sometimes there's a confirmation number.
6 confirmations, or no, if you, sometimes you can have this weird fork where different blocks are found that meet the conditions in different parts of the network, and they get broadcast out, and your software, the node, can say, hey, there's 2 that match. So I got to keep them both and figure out which one gets added onto, and so the longest chain, and then you orphan the rest of them. And that's why you see these people who say 6 Confirmations, fine, you got to balance. If you're putting money into something where you can transfer out to kind of fiat currency, dollars, euros, whatever, then I'm going to require 80 confirmations. You know, so there's people who sort of, there's a level of trust in the transaction that varies. Okay, do people want to actually try to install mining software and get going?
Yeah.
Okay.
You should put a big caveat that it's not advisable to mine on a laptop.
Yeah. So you can do it as a test, as a learning thing, but leaving it running at full speed, full temperature, yeah, probably not. So if you get through this tonight, you should be able, many of you, it's not super simple, many of you should be able to actually see some coins kind of dribble through, and sort of that's another kind of light bulb that goes off. So there's a concept called a mining pool. So to do this, to search for this hash within the time window just on your own is, even for something like Dogecoin, is yeah, you'll get one eventually, but probably not in the next couple hours. So if you join a mining pool, the pool divides up the work. These things are easily parallelized, so they divide up the work. You crunch a little bit, throw your results back to it, and whoever, if the combined set of worker software that's attached to the pool finds the block, then they divide up the reward across the participants with different algorithms. So there's two things you would have to do to kind of get started. One is create an account, throw away or whatever, on a mining pool. Once you've done that, create a worker, which is like, you can say, oh, I'm going to run all of these processes all pointing to my account. I want all the credit to come to my account. But you need at least one. And then you need to have some mining software and point it at that. Does that make sense?
Yes.
OK. So lots of different pools, lots of different politics or culture around the pools. The one that might be fast enough, it has enough power in it right now, that's pretty easy to set up, is one called Doge House. And in the, there's a link to it in that Word spreadsheet, or the text online, and the spreadsheet link on the left top cell. So if you go there, Doge House, create a new account, you'll have to confirm your email, find your way to the side that says, I want to add a worker, you need to create a name and a password for the worker, and then you'll get to something which is a little bit dicier, which is the actual mining software, but we can walk around and start working on that. I know some of you have gotten your miners connected and starting to buzz away in the background. So why don't we kind of talk a little bit about what if you leave them running, what you will see in a little bit. So how many folks have actually gotten something running and connected to the pool? That's excellent. Excellent. OK, great. So what hash rate are you running at? So in your little miner window where it says, 7 kilohashes per second, 3 kilo, 1.2. So the people that have it running, what are you seeing? 3.3? 3? Good? 3.9, excellent. 8.9, great. Okay.
Helping, I was seeing an average of 4.
79. So you're running with a GPU with 79. That's good. Okay, great, great. Excellent. So if you leave it running for a while, I'll show you a little bit of the user interface on some of this software, and the stability of it is a little bit wonky. So it's an early, not only early days, but a lot of this is open source software, so people are like, oh, I might want to run a mining pool. Why don't you just take this project and fiddle with it? So it's a little bit weird. But so this is my, I'm logged in to a dashboard here, and I can see down on the right-hand side of the dashboard, you'll see how many coins in orange you've received but haven't been confirmed. So let's see if I... So here, at the moment, I've got I took an old PC, cheap CPU, Celeron, $40 motherboard, but a $600 graphics card. So that is running, and at the moment I've got, it's sitting there with 859 coins confirmed that it's credited me with my share of the stuff, and I got 264 unconfirmed. And then if I come out of Zoom, I don't think I'm making money against my electricity bill, but I haven't actually metered it. I have something I can. On the left-hand side, if you go to my account under transactions, that's where this particular pool has, down at the bottom, you can kind of see the specific individual kind of credits that you get. So I can filter, it's kind of goofy here. I'll filter it for credit because it shows me all the fees that I'm paying and all that kind of stuff. And filter, and then it's kind of hard to read, but I can see that, okay, 14.2 coins at 120, 14 coins at 119, 12 coins at 118. I think that's GMT. So I'm getting, a pretty steady drip of that. And then down below, confirmed. So I had in a couple of pools played with at home. I have this machine with a $600 graphics card. I have a cloud instance, DigitalOcean, $5 a month virtual server, and I have at home a Raspberry Pi. So the Raspberry Pi is like below the threshold. Every now and then I'll see it say, yeah, I see you're alive, and here's a little something. The DigitalOcean droplet is earning, I don't know, maybe $10 a month, and I'm paying $5 a month for it, so it's their electricity. It's kind of weird. And then at home, this machine that's sitting in the corner is doing about 1,000 Dogecoin every 10 hours, 15 hours. I have not spent any time to optimize it. I've got friends who have these rigs. Like if you go to, how many people have a mining rig with more than 6 cards in it? Anybody here?
My friends.
Your friend, okay, good. Mining rig. So people get pretty crazy, right? So these are just standard graphics cards, but there's this whole like, oh, you can get extender ribbons, and you get multiple power things, and you get specialized chassis. You get a giant fan that you put behind the whole thing. So if you actually go online, you can find all kinds of comparisons about hardware costs, electricity costs, kind of mining rates, and there's a site called Coin Wars with a Z, which shows you, if you think about how many coins you can mine, that changes with difficulty. If you think about what those coins are worth, if you trade them across each other and then into something like US dollars or euros or whatever, that's always fluctuating. So people are trying to, if you're trying to figure out how to optimize the value of what you're creating out of your electricity, it's pretty messy. Aaron.
Okay, so I know a lot of people mine on Litecoin and then trade into Bitcoin.
Yeah, so you can mine on Litecoin and then trade into Bitcoin, and you may have more results for your electricity than if you were mining Bitcoin. And there's this whole, there's a concept called a multi-pool. So just as you're connecting your worker, your CPU power into a pool, there are multi-pools which on your behalf will be watching the trading and relative values and say, oh, you know what, we're going to switch all of your CPU power over to Litecoin. Oh, no, back to Dogecoin. Oh, no, over to Aurora Coin. So there's people sort of creating these strategies that automate your results, but it's kind of adversarial. So the recent Dogecoin change to the protocol, it turned out that there was a way, because the Dogecoin protocol worked, that you could identify, they had a random reward for blocks, and there was a little bit of a hint where you could identify, okay, the next block, is it a good one or not? So the multi-pools would back off of the lousy ones and pile into the good ones. So they actually adapted for these, not bugs, but quirks in the algorithm, and it totally made it hard for, ordinary folks to kind of compete. So the Dogecoin folks said, that's not fair, that's not part of what we're about, so let's change it. So if you do this for real, it's shifting all the time, and it's hard to say. I don't know. I paid $600 for a graphics card at an experiment to see if I could pay it back. The first month I got like $60. Second month, $40. I don't know if I'll pay for that card. I might. Okay, so we wanted to try one quick thing, which is, as an application developer, these platforms totally change what you can do and how easy it is to write certain kinds of applications. So to make that real, this is very, very simple and quick if you're on Twitter. If you go to tipdoge.info and authenticate with your Twitter ID, that will create a TipDoge account or a linkage. And then you'll get an address where you can send Dogecoin to TipDoge. Okay, so the analogy here was think of a wallet as a wallet address as a separate balance or store. All of these services, like, okay, if you're successful mining into this mining pool, you kind of are collecting a balance there, which then you can transfer out. If you sign up for TipDoge, if you sign up for a gambling site, you're going to they're going to give you a wallet address that's yours that you can make a balance in. So it is like a Metro card or something like that. Basically, I want you to try these three things, which should take you a minute or two. Go to TipDoge info. They'll make you authenticate, and they'll give you an address. Transfer in a little bit of Doge to that address, so send to that address. And then they have a simple syntax, and I'll go to Twitter and kind of show you some of how that works. They have a simple syntax that you can use on Twitter to sort of send a tip or send Doge to someone. Okay, so how many people sent a tip all the way through the end? Okay. So how many folks here are software developers, product developers? So how do you think about this what it would take to write this app. So not too much. So, but the app is letting you transfer units of value to person. So, but the TipDoge does not have to keep a balance. You know, it can be out there in the blockchain. It doesn't have to do any transaction processing. There, you just sort of post that out into the network. It's not even doing any kind of identity. Okay, your Twitter's handling the identity management, and if I see that tweet from that handle, I trust Twitter that it'd let you log in and send that message. So they've written a bot that watches a feed and connects to the Dogecoin network. Yeah, they have to say, oh, I know that @ReadSturdivant internally I've kind of generated a key pair, and that's the private key that I'm going to use for him, and that's the public key that I'm going to use for him. It doesn't have to know what my balance is. It can look it up in the blockchain. It doesn't have to do any kind of transactional stuff. That's posting a message out into the network. It doesn't have to do any kind of go out and get a contract and sign a deal with some kind of Stripe or payment processor. It doesn't even have to know how you're going to take the money out on the other side. So the thing about these protocols is they radically simplify. I mean, even if you had a FastPass with a balance and a MetroCard with a balance and a Charlie card with a balance, and you wanted to move a balance between each of those things, how are you going to do that now? But with these kinds of technologies, you don't need anybody's permission. It's a uniform standard approach. It dramatically simplifies this. If you actually go and look at we won't do this tonight for a few reasons, but and we listed a bunch of the gambling sites. So hey, if you want to write a video poker thing that moves, it's not real money. Yeah, you can go to Cryptsy and transfer it to Bitcoin and go to transfer that. Cryptsy doesn't do real money. It's an exchange. It's just a pure digital currency exchange. Cryptsy's not touching real money, but yeah, you can transfer it from your Cryptsy account, Dogecoin in, convert it to Bitcoin, post that out to your Coinbase account, and then from Coinbase go out into US dollars. So yeah, there's all these people writing dice games, roulette games, video poker, and the code you have to actually write has become so thin. So these, not just Dogecoin, but all of these technologies is a whole nother platform for easy experimentation.
Yes, did I get you right? Did you imply that one's balance is encoded in the blockchain? Was that right?
It can be. It doesn't have to be. So that way, if you look at things, so is your balance for these apps actually in the blockchain? The history of your transactions for that address are in the blockchain. So you can follow it back that says basically, oh, the first time we see this address, it was the destination for a certain number of coins. And then anything that's happened to those coins from that address is also in the blockchain. So given an address, you can find out, does it have any balance?
How are you defining address?
It's the public key.
So that's not necessarily bound to, or has any, that does not necessarily have any reference to a Twitter account, per se, right?
Nope, only within TipDoge. Yeah.
So yeah,
David.
everyone's like all account balances, everything is public, but the problem, or not the problem, it is anonymous, as in that doesn't have like your name, address, etc. associated with it. However, they're all still associated, all the transactions, but I can't tell, you don't know the difference between looking at the blockchain, me going to an ATM, or me going to, you know, give it to someone else. Like, you just see a chain of transactions that you can inspect and see what wallet they're currently attached to, but those don't attach to like a person's identity.
So if there, well, there's who has access to the private key associated with that public key? Yeah, I mean, there's a lot of things that you can do that help make it easy for that to happen. As an example for all of you, it's like, okay, I have, it's like when we were saying, I was robbed from this Dogecoin thing. It's like, okay, I have a $10 balance in Cryptsy, which is a digital exchange. It's not a lot, but it can be transferred to US dollars, so, you know, like all these things. So it's like, I use two-factor auth. It's like, I don't know if earlier tonight, Dogechain info was compromised, or if I've accessed that site from 2 machines, if one of my 2 machines was compromised, I didn't use two-factor auth on that. But for things that I play with more seriously, yeah, I do. Some of the things to go explore, if you're interested in this kind of stuff, are the non-currency, non-stored value uses of this technology. So there's some really interesting early projects and a lot of hypotheticals. Like there's a project called Twister, which is using the blockchain concept for publishing, blogging. So imagine that you wanted a distributed, non-centralized, known, pseudonymous, kind of known identity. Whoever wrote this is also the person who wrote that. And their identity can't be forged, their postings cannot be removed from the history unless they do it. So there's uses, it's just simply the peer-to-peer concept, using proof of work to validate that these are legitimate additions to the history, the shared ledger, but you can use it for publishing, you can use it for DRMs, like, digital goods, you can use it for notarizing and saying, hey, I wrote this article on a certain time. I'm not going to tell you what it is, but I posted that hash of that content into the blockchain at a certain time, and anybody can prove it. I can prove it. So if you look at non-currency, non-stored value uses of these technology, there's a huge set of possibilities around that. Plus, you can buy T-shirts online with Dogecoin. OK, Doge outlet. This is where you realize that Doge is, at the moment, not that valuable in the real world. Nice. 40,000.
Wow. I don't know. It's better than some other countries.
It's not bad.
Free international delivery.
Free. OK, great. Thank you so much for jumping in. It's great.